and 2. We're going to talk about permutations today, which is really just the slots that we looked at last time. It's kind of thinking about different ways that we can arrange a certain number of items for a situation. So I wanted to look at this opener because I thought it was kind of cute. It said, we opened this section with 6 jokes about books. So Groucho Marx said, outside of a dog, a book is man's best friend. Inside of a dog, it's too dark to read. George Carlin said, I recently bought a book of free verse for $12. Stephen Wright said, if a word in the dictionary was misspelled, how would we know? Henny Youngman said, I wrote a book under a pen name Bic. Oh, y'all aren't looking at any of these. All right, a bookstore is one of the only pieces of evidence that we have that people are still thinking. And I honestly believe that there is absolutely nothing like going to bed with a good book or a friend who's read one. Okay. So what they're saying is if you're going to read these jokes, you could read them in different orders, right? And we might want to know how many different ways it is that we could read these particular jokes or deliver these particular jokes. And so I would just notice that there were, 1, 2, 3, 4, 5, 6 different jokes. And so I would make 6 slots, and then I would have 6 choices for the first joke, but the second joke, I can't read the one that I've already read, right? So then now I only have 5 choices, and then 4, 3, 2, 1. And so you have some slots, and I like to draw little lines, and you can just use the fundamental counting principle then, which we learned last time, to multiply these through to see that you have 720 different ways to deliver the 6 jokes about the book. And so it would be very tedious, but you could actually write out all 720 different ways to do that. Like the Seinfeld, the Youngman, the Carlin. This is one example, Carlin, Marx, Wright, Diller. That's how they delivered it, but you could mix them up, obviously. Okay, so such an ordered arrangement is called a permutation of the 6 jokes, or a permutation is an ordered of arrangement of items that occur when no item is used more than once. So each joke is told exactly once. And the order of arrangement makes a difference. The order in which these jokes are told makes a difference in how they are received. So that's kind of how you want to think about it, that the order makes a difference. So no item is used more than once, and the order of the arrangement makes a difference. Okay, so let's look at a couple more problems. Similar problems. It says there are 8 performers who will present their comedy acts this weekend at a comedy club. How many different ways are there to schedule their appearances? I found this problem, these types of probability questions can be tricky, and especially as we get more, we learn a few more ideas in probability. Because to me, I'm thinking, well, are they going to have, over the weekend? Is it over 2 days? And, is it just that they're going to do 4 each night or something? But they don't say anything like that. So all you want to think is that I guess you're going to go to the show and you're going to watch all 8 performers, which could be kind of exhausting. But anyway, so you have 8 performers, 1, 2, 3, 4, 5, 6, 7, 8. So the first act you have 8 choices for. The second act, though, you only have 7, then 6, then 5, then 4, then 3, then 2, then 1. So those are your choices. So you can come in on your calculator and you would say 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. And so you have 40,320 different ways that you could schedule those performers. Okay, now if you have if you wanted to arrange 5 of your favorite books along a small shelf, how many different ways can you arrange the books, assuming that the order of the books makes a difference to you? Then you could have 5 choices for the first slot, 4 choices for the second slot, 3 choices for the third, 2, and then 1. Okay? And this would then be, you could just multiply this out, and we can do this in our head maybe. 5 times 4 is 20, times 3 is 60, times 2 is 120. So the 120 ways to arrange them if order matters to you. Okay, now there's actually a notation for what we just did. 8 times 7 times 6, repeating the multiplication down by integers until you get to 1. There's a notation, and it's called the factorial notation, and it's a little exclamation mark. And so 8 factorial means exactly this. 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. New symbol in mathematics. So 5 factorial is this. Okay? And so that's what this that's why they say n factorial means n times n minus 1 times n minus 2 all the way down until 3, 2, and 1. So for example, if you had 12 factorial, it would mean 12 factorial means 12 times 12 minus 1, which is 11. So 12 times 11 times 12 minus 2, which is 10. So 12 times 11 times 10 times 9 times 8. So it is just this new operation that you're learning. You now know that if I wrote 53 factorial, I would mean take 53 times 52 times 51 times yada 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 all the way down until you get to 3 times 2 times 1, which is a huge number. 53 factorial is a big number. And this formula, and it turns out that by definition, we just define 0 factorial to be 1. We do, and just don't try to understand it. Definition. It is what it is. It seems strange. It seems like 0 times itself is 0, but we're not worried about it. On your calculator, on the TI-84, the factorial button actually lives, and you may find the factorial button if you're using a different calculator somewhere too. On the TI-84, it lives under the math button. And if you go over, you have to do the right arrow to the PRB, which is your different probability choices. And you'll see that the 4th choice on your calculator is actually the factorial button in the math and then over to probability. So if you wanted to do 53 factorial, math, over to probability, and then down to 1. Now let me tell you that sometimes it's too big and your calculator can't do it. I think 53 is going to be okay, but I could get an overflow error. Okay. E to the 69 means move your decimal to the right 69 places. So that's a huge number. That's a huge number. Okay? You got to move that decimal way over to the right. You know, if you try to do like 500 factorial, it will give you an overflow. Let's see, I'll just put a 1 in here. So 513 factorial, it's going to tell me that's too big. I can't do it. Because you can imagine 513 times 512 times 511. So 513 factorial is a number. But you must think of it as just 513 factorial. Don't try to represent it in a method that you're used to because it'll hurt your hand to have to write it that much. Okay? So these big numbers exist and we can play with them. And one way we can play with them is to use notation that means it's a really big number. So that's kind of why we have this new notation. In higher mathematical thinking and in all types of applications, sometimes you have to deal with really big numbers. So we need a way to describe them without having to write all the digits. Okay, so this is kind of fun, and you can do this without your calculator, and I hope you will. 21 factorial, think of that as 21 times 20 times 19 times 18 times 17 times 16. How about instead of keep writing 16, 15, 14, I just write 16 factorial. Say it again? Yeah, good. And so then down here, I have 16 factorial, which I could write as 16 times 15 times 14 times 13. However, I noticed that thinking of 21 as 21 factorial is 21 times 20 times 19 times 18, 17, 16 factorial, I was able to just cancel that out like that. Okay? And so then all I need to think about here is this, and this I'll have to actually do with my calculator, 21 times 20 times 19 times 18 times 17. Which is 2,441,880. Okay, so 20 factorial means 20 times 19 times 18 times 17 times 16 times 15. And how about I stop right there and put 14 factorial? Does that make sense? Okay, so I'll put a 14 factorial down here, and those cancel, and then I can just do 20 times 19 times 18 times 17 times 16 times 15. So 27,970,200. 907,200. Okay. Now I will model. You can do this with your calculator. You could do 20 factorial, so that would be math, and then over to probability, and then down to choice 4, divided by 14, and then math over to probability, and down to choice 4. Yeah, it's kind of tedious.
Yeah.
Some calculators you can actually program to have like a quick key of like quick functions that you use a lot, and then that it might be worth it if you're using a factorial button a lot to have it a little faster access. Okay. 120 factorial divided by 118, that's going to be 120 times 119, but then times 118 factorial cancels with that 118 factorial, and so you have just 120 times 119. Which is 14,280. This is kind of fun. This homework will probably be pretty quick now that you understand the notation. Some of you may have already done it because the due was due. I messed up on the due date. If I haven't covered the lesson, obviously it's not good. I fixed it now though. 8 minus 5 factorial is what you want to do here is you want to do the subtraction first. And we don't have like a distributive property for factorial or anything like that. So just do the subtraction first. And so this is 3 factorial, which I can do that one in my head. That's just going to be 6. 3 times 2 times 1. I can do up to about 5 factorial in my head. All right, now this is 5 factorial. Now I have 5 minus 2, which is 3 factorial. So I can think 5 times 4 times 3 factorial over 3 factorial. Those cancel, and I get 20. You could do that with your calculator if you wanted as well. Okay, now I'm going to go back to the textbook because I copied that, this next part of the notes, and it's not quite as much as I wanted to copy, so let me go in and set the stage for the lesson. Okay, so we're going to get to this idea for permutations, and it turns out that a permutation you can actually just always do with slots. But you're going to hear the word permutation and the word combination. You should need to know the difference. So I'm going to talk to you about this formula for calculating permutations and such. Okay, it says you are a coach of a little league baseball team. And I think this is kind of appropriate because right now there are so many little mini baseball players out. Have you noticed? Every time you turn around, there's little babies. Like I live by the Woodway Family Center, and there's these little babies. They're this tall, and their daddies are tossing, and they're like scratching their thumbs. They don't know what they're
picking flowers.
Huge. It's really cute. All right, but anyway, they're everywhere. It says, you are the coach of a Little League baseball team. There are 13 players on the team and lots of parents hovering in the background, dreaming of stardom for their little Derek Jeter. You need to choose a batting order having 9 players. The order makes a difference because, for instance, if bases are loaded and little Derek is 4th or 5th at bat, his possible home run will drive in 3 or 4 additional runs. How many batting orders can you form? So you can choose any of the 13 players for the first person at bat, but then, you can just think of this as 9 slots, and it's 13 times 12 times 11 times 10, just like you would do this one without me even having to have this discussion with you, okay? Well, and then you would get it with about 260 million batting orders that are possible. So, and each batting order is a permutation because the order of the batters makes a difference. The number of permutations of 13 players taken 9 at a time is this. So this is the number, so this is this new language now. The number of permutations of 13 players taken 9 at a time is this 259,459,200. Now, there's actually a way to come up with a formula for this instead of using slots. And it is, if you were to take 13 factorial and then divide by how many you had left over, you know, how many players are not going to get, which is that, because you only have nine slots, it's 13 minus 9, so that's 4 factorial. If you take 13 factorial and divide by 4 factorial, then that is going to give you the same answer. Okay, and so then that's the number of permutations of 13 things taken 9 at a time. Is you could also think of it, if you didn't want to think of the slots, as 13 factorial over 13 minus 9 factorial. And so this is a special notation that we're going to introduce. Am I looking at this and y'all are going, what?
Yeah.
And I get nothing from you. I'm talking, you're nodding your heads. Man, I'm recording this too. Do you want me to redo it all?
No, it's all right.
Well, yeah, okay. Next time, speak up. If I'm looking at the computer screen and you're not looking at the same thing, maybe you should. We're trying to make this together. Yes, I need some audience
I
participation.
did have some erasers in here.
Okay, I guess you guys were following me or just nodding your heads slightly. But anyway, here's our 6 slots. So if we wanted 13 players taken 9 at a time, is this 259,459,000, whatever. Okay, so another way to think of it, besides the slots, is 13 factorial divided by the difference, how many you have left over, which is the 13 minus 9, or the 4 factorial. So that's what we're talking about right here. So the number of permutations of 13 things taken 9 at a time is this 13 factorial divided by 13 minus 9 factorial. And we have a special notation, which is 13p9. Okay, it's just new notation. And it's used to replace the phrase, the number of permutations of 13 things taken 9 at a time. So this new notation, 13p9, means 13 factorial over 13 minus 9 factorial. The numerator of this expression is the factorial of the number of items. In this case, it was 13 team members. The denominator is also a factorial, and it's the difference between the number of items and the number of items in each permutation. So, you know, each different lineup is a permutation, and so then you look at the difference. Okay, so they say the notation NPR means the number of permutations of n things taken r at a time. And so that takes us to this formula that is on your notes, but is not, it's not always used nearly as much as the combination formula, which we'll look at in a minute, in the next lesson. And that's because this can be done with slots, but it's good to look at. All right. So if we want to use the formula to do this problem, 11 permutations from 11 items, and we've got 6 permutations, we can do, number of possible permutations of, in this case, R, which would be 6 items, are taken from 11 total. So you have, what you'll do is you'll do 11 factorial divided by 11 minus 6 factorial. So this is 11 factorial divided by 11 minus 6, which is 5 factorial. So this is 11 times 10 times 9 times 8 times 7 times 6 times 5 factorial over 5 factorial. And so you can do that on your calculator. 11 times 10 times 9 times 8 times 7 times 6. So this is 332,640. Okay? You could do that with, there's actually a button on your calculator. And the button on your calculator, NPR, you would do, what that means is you do 11, you'll say the 11, and then to get the NPR function, you go math, and then you go over to probability, and then you see it there, it's number 2. Do y'all see that? So you hit that, and then put in, our R was 6. So you put in a 6, and it gives you the same answer. So it's kind of fun. right? And I mean, I'm just thinking here that I don't want you to be restricted to a particular computer. You could go into the internet and we could just try permutation calculator. Look, it's already right there. Boom. And come in right here and look, there you are. You got, your N is 11, your R is 6, and then we would say repetition is not allowed, right? Because you can't play, and there you get the same number. And then it gives you a formula. Isn't that lovely? All I did is just go Google permutation calculator, and I found something. And there were a bunch of other choices. So you could, if you wanted on your window, you could have the same, you could have that open. I'm sure that Excel probably has a permutation thing. If we wanted to figure out if it had it, you might just type in permutation. Now I'm not, it may not be, they may not have one. No, they don't have it. So I was thinking it might have it. I think it has factorial button. Calculate the or permutation of a number. Let's see. Okay, so it's the fact function, but it looks like it doesn't have a permutation. So you can get it to do, like if we do equals fact of 5, that's the one I know, is 120. So there's lots of different tools that you can use out there in the world. You don't have to use the TI-84 if you don't want to have to multiply by hand. So just remember that. Okay, so if we want to do number 9, okay. We want to do number 9. And let me just say that if you wanted to do this one just with the slots, how many slots would you have? From this, how many slots do you have? You have 6 slots. 1, 2, 3, 4, 5. So you guys were all just waiting for someone else to answer. All right, and so then this is going to be 11 times 10 times 9 times 8 times 7 times 6, which is how they got this here when those canceled. Okay, so are you with me? You can do it with slots, you can do it with your calculator, you can do it by hand, however you want to do it. So how many slots do you have on number 9?
3.
Good. And then you have 8 things to pick from. So maybe this is like a committee and you have 8 people that get to have a chance to be in it. So this would be 8 times 7 times 6. And so 8 times 7 times 6 is 336. You could do this as 8 factorial over 8 minus 3 factorial. And so that would be 8 times 7 times 6 times 5 factorial divided by 5 factorial. And you would see you get the same. You're going to get the same answer. And then, of course, you can also do it with your, if you have a TI-84. I can come in here, actually, if I do second entry and then second entry again, I can edit this. Put a 3 here and an 8 here. And I'll get through this. So, however you want to solve it, or you can go to that cool website that I found. Okay, 8, and then we have 8. All right, so that's going to be 8 factorial over 8 minus 8 factorial, which is 8 factorial over 0 factorial. But you learned 0 factorial was 1 by definition, so this is just 8 factorial. The other way you could think of it is this is the number of slots you have, 8 slots, 8 items, so it's just going to be 8 times 7 times 6, which is this new button you learned. 8 factorial, 8 times 7 times 6 times 5 times 4 times 3 times 2 times 4. Anyway, we can get 8 factorial, 8, and then math over to probability, and then choice 4. 40,320. If you just have a small calculator, of course, you can just, multiply it out. 5P0. Okay? 5 people, nothing to offer. That can only happen one way. All right, so that's going to be 1. But maybe the formula helps you a little bit better. It's 5 factorial over 5 minus 0 factorial, which is 5 factorial over 5 factorial, or 1. But, there's only one way to do nothing. Okay, deep thoughts. All right. Use appropriate permutation to solve the following formula, or the following situation. A club with 6 members is to choose 3 officers: president, vice president, and secretary/treasurer. If each office is to be held by one person and no person can hold more than one office, in how many ways can those offices be filled? Okay, so we have 3 officers, and we have 6 members. So you have 6 choices for the first, 5 choices for the second, and 4 choices for the third. So that's 30 times 4, which is 120. Do y'all agree? You could, if you wanted, do as a permutation. Think of this as a permutation. It's 6P and then 3. So then you could do that on your calculator if you wanted. Or you can do it with the formula 6 factorial over 6 minus 3 factorial, which is 6 times 5. Okay. For a segment of a radio show, a disc jockey can play 9 records if there are 12 records to select from. In how many ways can the program for this segment be arranged? All right.
I was harassed for this question.
You were what?
Harassed about that question.
By who?
Just from friends of mine. I was showing them a while earlier. They're like, excuse me, what are records?
Oh, I know. It's kind of funny.
I mean, how many, and the CDs, or how many songs on each record can they play? Or,
Yeah, all kinds of choices. 1, 2, 3, 4, 5. Well, we have 9 records, and there are 12 or 9 songs. 1, 2, 3, 4, 5, 6, 7, 8, 9, and then 12. So this is going to be 12 times 11, and then you have 10, and then you have 9, and you have 8, and you have 7, 6, 5, 4. Okay, and so you can type that in. You have lots of choices. 12 times 11. Seems like they always play the same song though. Twice. Because there's that one song you really like, you want to hear it again. Times 9, times 8, times 7, times 6, times 5, times 4. So 79,833,600. 79,833,600. Have you ever listened to that? I don't know if you guys have ever experienced satellite radio with a New York car. And they have that channel. There is a channel that's called like something 20. And I think it only plays like the top 20 songs. And I wonder if they use some sort of algorithm to randomly, play them all day long. It does seem like you hear the same song over and over again, but they are probably going to say, yes, you may hear it over and over again, but the order that you're hearing it is different all day long. The order in which you're hearing it all. I don't know. Okay, in a race in which 10 automobiles enter and there are no ties, in how many ways can the first 3 finishers come in? All right, so you have 10 choices, and then 9 choices, and then 8 choices, because there's 3 finishers. See, I'm inclined to do permutations with the slide, but I need to show you the notation, because when we get to combinations, it's trickier, and so you're going to kind of be glad that you've seen this notation. So we'll do 10 times 9 times 8, which is 720. Oops. Okay, and so that is the lesson in section 7.